Okay, gang, let's start talking about logarithms, okay? What are logarithms? Well, logarithms, simply put, are exponents, okay? Let's come over here and clarify the situation here, okay? Let's say I'm dealing with a situation where I've got a base b. Remember, bases are what? Positive numbers that are not equal to 1. So b is greater than 0, not equal to 1, okay? B to the x power is equal to c, presumably, okay? So I've got an exponential form here written this way. B to the x power is equal to c. This thing is called what? The base. This thing up here is called the exponent or power, right? And this thing on the other side that this is equal to, I will just call the value of the exponential. Okay, so that's the value of the exponential. Well, we can actually rewrite this situation here, and we can say x, the exponent, is what? The logarithm, this is how you read it, the logarithm base b of c. Okay? So basically, the logarithm base b of c is the power you have to raise the base b to actually get the value c. Okay? So you can see that x is actually an exponent, so the logarithm here is actually an exponent. Now, I think it's important for you to be able to read this properly, right? Reading mathematics is important as writing mathematics here. Logarithm base b, okay, so the b is subscript here, of c. Logarithm base b of c. X is equal to the logarithm base b of c. Okay? Notice that in both these situations here, these are saying the same thing in two different ways, okay? Notice that the base here is what? B. The base here is still b. And the value of this whole thing is going to be the exponent, okay? So our first order of business, in order to get used to the idea of using logarithms, is to rewrite some exponential equations in logarithmic form. So this is the first thing you'll be doing in section 6.4. So here we want to rewrite this in logarithmic form, okay? So it says 2 to the third power is equal to 8. Now, I'm going to write log, okay? Logarithm base what? Well, base 2. That's the only base we're dealing with here. So it's going to be a logarithm base 2. So I make that 2 subscript, okay? What's the value of the whole exponential here? It's 8, okay? And then on the other side where this is equal, you should have what? The exponent, okay? So these two are saying exactly the same thing in two different ways. 3 is the power you have to raise 2 to get 8. Okay? If you want, some people like to incorporate parentheses there sometimes. Okay? I will do that now and then. Okay? Just to make things clear. Okay? All right, let's do some more of these. All right, so I've got a collection of problems here in that section here. I've got 2 to the 5th is equal to 32. 2 to the 5th power equals 32. Okay? So I'm going to rewrite it logarithmically. Logarithm base 2 again. Yeah? What's the value of the exponential? 32. And that should, remember, a logarithm is what? An exponent. The only exponent I see in there is 5. So this would be saying exactly the same thing in two different ways. So there's our answer. The power I have to raise 2 to get 32 is 5. Okay? All right? How about this one? Okay, you can take a second here and do it yourself. All right? Logarithm base what? What's the base over here? 4. What's the value of the exponential? 1/16. What's the exponent? -2. Okay? Alrighty. Logarithm base 4 of 1/16 is -2. Okay? E to the second power is 7.39. Do you remember what E was? E was the base of the natural logarithms, 2.71828. Remember I showed you the other day? Okay? Well, anyways, could you rewrite this? Okay? Logarithm, well, what's the base? The base is E, so I could say logarithm base E. What's the value of the whole exponential? 7.39. And this is supposed to equal what? What's the exponent? This is going to be an exponent. This whole thing is the value of the exponent over here, so that should be 2. Now, one last thing I would throw in here, and I'll mention this probably several more times here. The logarithm base e is also written this way. Remember ln? Okay, so this would probably be our preferred way of writing it. We usually don't write logarithm base e. Instead, we write ln. It wouldn't be wrong, but this is typically what we would do. By the way, this is only an approximation. E squared is just about 7.39 to 2 decimal places. So this is really an approximation here, as you might guess. Okay, anyway, get it? All right, so there's some examples of that. Okay, let's go ahead and go the opposite direction. Now you should be able to go back and forth between these. Take an exponential statement and write it logarithmically, or take a logarithmic statement and write it as an equivalent exponential. Okay? All right, let's try that. So let's take problem 14 in section 6.4. Okay? How would you read that? Logarithm base 2 of 16 is 4. Okay? Now I'm going to rewrite that so it's an exponential equation. Okay? So what's the base here? Logarithm base 2. Okay? What's the exponent involved? Well, remember this whole thing is 4. That's always the exponent, right? 16 is the value of the exponential. So this is saying 2 to the 4th is 16. By the way, in all the problems that you're working in this and all the sections, John Grimma does indeed tell the truth, so this should be a true statement at the end also. Okay? 2 to the 4th is indeed 16. All right, how about this one? Logarithm base 5 of 1 is 0. Okay, my base is 5. What's the exponent? It's 0, right? All right, well, there's only one number left. That's going to have to be the 1. Is it true that 5 to the 0 power is 1? It is indeed. Okay, how about this one? Here we can't verify this numerically because we don't know what x is really. We can actually figure out what x is here. Logarithm base 3 of x is 2. Okay, so the base is 3. The exponent is the entire logarithm, so that value was 2, and that would be x. Okay, so 3 squared is equal to x. You could also write what? 9 is equal to x, which is in fact the case here. Okay, now I don't know if I've mentioned this before or not, but I'm going to now. I've just got plain log of x equals 4. Now, if the subscript is missing altogether on your log, on your logarithm, see how there's no subscript here? It's implicitly logarithm base 10. These are called common logarithms or Briggsian logarithms. Okay? Logarithm base 10. So if you don't see a subscript, what base is it? It's base 10. Okay? All right. So with that in mind then, just imagine that the base is 10 there. So we're going logarithm base 10 of x is 4. So our base is 10. The exponent is 4. And that should give our x value. Okay? In particular, x is actually what? 1 and 4 zeros. That's 10,000. Okay? Try this other one. ln of x is equal to 1. Now we already explained earlier that that actually means what? Logarithm base e of x, right? Logarithm base e of x, 2.71828. Okay, so you could just imagine the base is e here, so what would this be? E to the power 1 is equal to x. Now e to the first power would just be e, right? So we could actually say x is the value e, but that's more than we need to do here. Okay? Alrighty, I hope this is making sense. Okay, just as an intro. Okay, there's another subsection here where they're asking you to find the value of a logarithm without a calculator. Okay, now let me show you different ways of solving this. Let's see if you can do this in your head, some of these. Okay, I'm going to explain it kind of verbally, And then I'll be more formal about it by writing it this way, like we did in the last examples here. Okay? The logarithm base 3 of 3. So my base is 3. What power of 3 yields 3? The first power. So our answer should actually be 1 here. Now let me show you that that's correct here. And if you can do that without writing all the things I'm about to write, then do it. That's good, right? Now if I was to give this a name x, this would be equivalent to going what? 3, the base, right, to the x power. The whole logarithm is an exponent. 3, which is equal to x. So it's 3 to the x is equal to 3. What does that imply x is? X is 1, like we stated. 3 to the first power is 3. Okay? How about this one? You do this one a little more quickly. What power of 3 yields 9? How about 2? Okay? I think the answer is 2. What would this be equivalent to? 3 to the x power is 9. Okay, this is, I essentially was doing this in my head here. X is equal to 2. It is indeed true that 3 to the second power, or 3 squared, is 9. How about this one? Okay, this is equivalent as what? The base is 5, so it's 5 to the x power is 125. How many times do I have to multiply 5 by itself to get 125? The answer is 3. 5 to the third power, or 5 cubed, is 125. How about this one? Okay. This would be equivalent to 2 to the x power is 32. That would imply what power of 2 is 32? It turns out to be 5. Okay, 2 to the fifth power is 32. If I multiply 2 by itself 5 times, I get 32. How about this one? This may be trickier here, so I invented a couple extra that he didn't have in there. Let's give that a name. What power of 9 is 3? I claim I don't need a calculator on this either. Well, this would be equivalent to what? 9 to the x power is 3. Okay, 9 to the x power is 3. Okay? Can you figure out what the power is? Well, let's look for a convenient common base. Remember when we were doing this? If you couldn't think of it, think of that as 3 squared is equal to 3 to the first power. Okay? That would mean what? 3 to the 2x is 3 to the first, and since exponential functions are 1 to 1, see how they're the same base? This means 2x is equal to 1. That means x is a half. Okay? X is equal to a half. So the logarithm base 9 of 3 is actually 1/2. Okay, later on I'm going to show you how to do this stuff with your calculator also. Okay? Alrighty? Does this make sense? This would be 9 to the 1/2 power is equal to 3. Do you remember when you raise something to the half power, it's like taking its square root. So this would be saying that the square root of 9 is 3, which is true, isn't it? Okay? Okay, I hope you understood that one. Okay, that was a little trickier. How about this one? Logarithm base 3 of 1/3. Okay. This would be equivalent to saying what? 3 to the x power is 1/3. Okay? Now this one, I'll just eyeball in here. Do you remember that that's actually 3 to the negative 1 power? Okay, so x must be negative 1. Or in other words, logarithm base 3 of 1/3 is negative 1. The power I have to raise 3 to get 1/3 is negative 1, right? 3 to the negative 1 power is 1/3. If you were able to get that without writing all that stuff, again, that is good. Okay? What power of 4 is 1/64th? Okay? What power of 4 is 64? The third power, right? 4 times 4 times 4 is 64. But I've got a reciprocal. Oh, reciprocal power. I'm thinking what? Negative 3 is our answer then, right? Okay, I claim the answer is negative 3. Let's go ahead and see it. 4 to the x power is 1/64. This is equivalent to saying 4 to the x power. That's actually 4 to the minus 3. So that means x is minus 3, right? Okay, so the logarithm base 4 of 1/64 is in fact minus 3. How about this one? Here I use some decimals. Okay, here I've got my base as what? 0.1. What is that as a fraction? Maybe it's easier if we think of that as 1/10. Okay, so I've got 1/10 the base. Raised to the x power is supposed to be 100. Okay, now I'm thinking of it as a convenient common base. This is actually 10 to the minus 1 power, and this one is what, 10 to the second power. So I've rewritten both of these in base 10. Now, a base to a power, you multiply exponents, so -1 times x is -x, okay, is equal to 10 squared. So I'm going to do what? From the one-to-oneness property of any exponential function, we can equate those exponents. So x is -2 because -x is 2. Okay, so there's our answer. So the answer is logarithm base 0.1 100 is in fact -2. This is equivalent to saying 0.1 to the -2 power is 100, right? And you could always check this on your calculator, even if you don't have what we call the change of base formula. You know, your calculator only has natural logarithm and common logarithm, logarithm base e and logarithm base 10. Okay? In fact, let's talk about this. You have to be able to do this. I already told you, right? Logarithm base 10 on your calculator, and most of the time when we write it, we just suppress the base, the subscript, right? So log of x is the same as logarithm base 10 of x. What did we call those? Common logarithms. And likewise, logarithm base e of x, we usually write as ln of x. What did we call those? The n is a clue. Natural logarithms, okay? Your calculators will typically have both of these. It has at least one of them. If it doesn't have both, it always has this one, okay? Some advanced calculators don't have this one, and you need something called the change of base formula for other logarithms. But that's future stuff. Don't worry about that. Let's just use our calculators now to actually do this. Now, when I do this, typically what I like to do is round to 4 decimal places, okay? Now, because this isn't going to be an exact number. The number is irrational, actually. But you should be able to do this on your calculator, right? Let me clear this maybe. I'll go like this. Logarithm of 5. Okay, now you have to, like I said, you have to be aware of how your calculator works here. And I get 0.69897. Now, if I'm going to round that to 4 decimal places, right? I go to the 5th decimal place. If that's 5 or more, then I add 1 to the previous digit and then truncate, right? Just chop it off. If I was to do that, then I would get my value as 0.6990. Notice that the last digit is a 0, but I'm including it anyway. I guess I should have said round to 4 decimal places, but I'll almost always say that. I'll tell you guys, almost always anyway. Okay, I better have 4 digits in the end here. See, when I add that 0, if I drop that 0 or I add that 0, it doesn't change the value, but it does change the information that you're getting across to a reader. If you actually include the 0 at the end, you're telling the person that you rounded to 4 decimal places. If I just cut it off at 0.699, yeah, I mean, it's exactly the same value, but it would be, look, someone would interpret that as that you rounded to the, 3rd decimal place instead of the 4th. Okay? Same value, but it's conveying a little bit more information. All right, I'm still preaching. Okay, let's clear this out. Okay, log, so I'm doing logarithm base 10 again, of 1 divided by 120. Okay, can you see that? Okay, this is going to end up being a negative number. Okay, once again, I'm going to round to 4 decimal places. So it looks like I get -2.6 0.079, okay? And then it goes what? 1/8. Since 8 is greater than 5, I add 1 to the previous digit and then truncate it, cut it off here. I guess I should be boxing in my final answers. Don't forget the negative sign on this, okay? Righty, this last one, natural logarithm of 3. On this calculator, that's ln right here is right underneath it, okay? This automatically puts parentheses in there, okay? So you guys have to be careful. Make sure you're getting these same answers, okay? All right, let's round to 4 decimal places. I get 1.0986 because the next digit is a 1. That's not 5 or more, so I simply truncate it like that. And I got my answer. And there it is. Okay? Alrighty. Okay, that should help you in section 6.4 then. Okay? All right. And we'll go on, and the next video we'll be talking about properties of logarithms. Okay? You're not altogether unfamiliar with these because remember, logarithms are exponents, and you guys know the properties of exponents, right? I hope so. Okay.